So, in terms of our discussion and conclusion, the way that we conducted our experiment and the execution was definitely adequate to test our hypothesis. I feel like our experiment design was very, very proactive and very efficient at testing what we wanted to test and get done. Our results did support our hypothesis. So again, we hypothesized that 50 degrees would be the optimum temperature, and that the reaction rate would be the highest then because the enzyme is not being denatured, but it is at a very high temperature, which means that the molecules are moving very, very fast. So again, our hypothesis was supported. The variability, again, like I said, between our results mainly just became for a few outliers. A lot of our results were kind of like what we expected. We ranged all the way from a 0.246 absorbance to a 0.2273 absorbance. Again, so they kind of, the two endpoints, two end temperatures were extremely hot and extremely cold, had similar values, but group 4 had the highest, was right in the middle at 0.7273, and again, the values kind of make that even bell curve. They were pretty similar to each other in the opposing groups. Along with that, like I said before, our results definitely were statistically significant. All of them were, so we could infer that our p-values proved that 50 degrees, or in our case 51 degrees, was the optimum temperature for our experiment, and we can conclude officially that 50 degrees Celsius is the optimum temperature for the enzyme reaction of trypsin. Some improvements that I feel like we could have made to our design was that if we had more time, we could definitely do more and more replicates. This would reduce the possibility of high variability, and definitely make sure that we could have a solid average that we could base our results off of, and then that would lead us to obtain more precise results. And I feel like our experiment is definitely very relevant when it comes to real life. A lot of people have GI tract issues, and I feel like a lot of people have trouble digesting certain things. People who are lactose intolerant, they can't handle dairy products, and azocacin is an example of milk, which is a milk protein. And if you're lactose intolerant, you have trouble digesting dairy products. So it's definitely relevant to show that, what temperature is most efficient for speeding up the reaction between trypsin and azocacin, because it definitely takes place within people, and maybe one day that people will invent something that can help individuals be able to catalyze their own reactions better in their body, not just with trypsin, but with other enzymes, so that digestion can be sped up and people can be more healthy in general. Thank you for listening to my presentation.